welcome to good evening everyone. Welcome to Computer Communication Network extra problem solving session. So today this is an extra session in which we will not be taking on some solved problems from a particular week. Rather, we will give a thorough overview of the entire course. So we will solve questions from the entire course, and we will also go through some key materials over which may not have covered in the class, in the weeks modules. So in the week modules we may not have covered these. So in this extra class we will be covering some extra topics and we will be solving some problems. So this will mostly be a theoretical class, so the problem solving might not be there much today. So with this, let's share the screen and get started. Okay, so uh, we'll first go through some questions. So define these questions might help you in the exam. So define computer network. So a computer network is a group of computer systems and other computing devices that are linked together through communication channels to facilitate communication and resource sharing among a wide range of users. So a computer network is a group of computers. So it's not just one computer, it's a group of computers which and other computing hardware devices that are linked together to form communication channels. So communication network is a group of computer devices which facilitates forming a link among our themselves, and this is called so there the types of computer network depend on the area of coverage. So this this depends area of coverage. We have multiple. So depending on the area of coverage, we have multiple types. These are local area network, personal area network, home area network, wide area network, metropolitan area network. So local is the smallest. After that, it's personal, then home area. So local area, then we have wide area network, which covers the entire region, suppose, of a city, and metropolitan area, which covers an entire big city, a metropolitan city like Bombay or Delhi. And then finally, we have the global connection of devices, which is known as the internet. So what are the network applications of computer network? One is file sharing, and another is email services, then accessing the internet. So actually any kind of application that needs connection or communication between smart computing devices will benefit from computer. Next, list any four unguided transmission media. So unguided media means unguided media means wireless. So in your wired communication, the beam is guided. So yeah. So in wired communication, so you have a wire like this. So this is a wire. So the signal is guided through the wire. It cannot go anywhere it wants. But in unguided signal, an unguided signal is basically a wireless signal. So it can go anywhere it wants absolutely. Okay, so it can go like this. So there is nothing stopping it. So it is unguided medium. So it can be radio wave, microwave, infrared, or satellite communication. Satellite communication again might have VHF, UHF, VHF, and UHF. Achha, so what are the types of error? Types of error means types of error in transmission. So if this is a error, so types of error in transmission. So there are two types of error. One in which you receive the wrong data at the right time. One is when you receive the wrong data at the right time. This is content error. Content error. And second is receive the right data at the wrong time. This is flow error. So the content of the data and the timing of the data are the two things that govern the fact that you will have an error or not. Okay. Next, list IEEE 802 X transmission standards. So we have 802.3, which is Ethernet, 802.4 is bus, 802.5 is ring, and 802.11 is this. So again 802.11 has Eight zero 2.11 has multiple generations. One is generation, one is 802.11n, 802.11 AC, 802.11 AX. So this is called Wi-Fi 6. This is called Wi-Fi 5. So this is the fifth generation of Wi-Fi, which probably you are currently using. So, and this is Wi-Fi 4, which you will still find in some old devices, like relatively older, I would not say old, but relatively older devices. Now compare a router and a repeater. So a repeater just transmits the data, plain and simple. So to give a summary, a repeater transmits the repeater will transmit the data as is. So repeater transmits the data as is, means however and whatever way it gets the data, it will just retransmit that, no questions asked. So that is repeater. But router transmits the data. Router also retransmits the data. So router also retransmits the data. But it reroutes the data according to need. So repeater's main task, repeater is something that operates at physical layer while router is at network layer. And repeater's main task is to boost the signal, because the signal gets attenuated gradually, especially in a wireless medium. Whereas router's main task is to send the data to the appropriate destination, help route the data to the appropriate destination. So one finds the path and another boosts the signal. So they are very different in their applications. Next question is, what is the function of network layer? So network layer is the layer that is responsible for creating the addresses. Network layer creates the addressing system which leads to efficient delivery of messages. So we have sorry for the hold up. Yeah, so network layer basically network layer does this. That network layer is responsible for addressing, creating address for devices and forming logical connection between devices to ensure error free delivery of packet. So network layer is responsible for creating address for device and forming logical connection between devices to ensure error free delivery. So network layer is creating the addresses for the devices and it is forming a logical connection. Now all the devices in a computer communication network may not be so close as to form physical connections, right? So in our local area network, you might expect physical connection between devices, but once you go outside the purview of a LAN, then you are not expecting any physical connection between devices. What you instead have is a logical connection. So if device A wants to send something to device B, it will form a logical connection, and that logical connection will form a logical connection. That logical connection will be responsible for the error-free delivery of the packet. So logical connection means in an abstract way they are connecting the devices. Now, classify the network based on geographical area and transmission technology. By geographical area, it means that the area that the network at its fullest extent serves. So a LAN will serve a building or an office or a small closed area, whereas a MAN can serve an entire metropolitan area, so a big city area like Bombay or Delhi. And a campus area network has maybe a close firewalled area. Like a campus area network has a close firewalled network inside which all the residents of a campus. So a campus is slightly bigger than a LAN, but much smaller than a MAN or a WAN. So WAN covers a area of city. So let's write it down. Text. So this text. This is one building or office. Next is this one area of a big city. Next, wide area network. So this covers an area larger than a city. So might be a district or something. So like a district. Okay. Next, we have campus area network. And one next is campus area network. The campus area network is self-explanatory. It covers the entire campus of a college or an office. So it is not as small as a building. It might have multiple buildings, but it is still a small geographical area. Okay. Now, in transmission technology, according to transmission technology, one is broadcast network. A broadcast network transmits to all. Whereas a point-to-point network transmits only to a particular destination device. So this transmits to all devices in an area, whereas point-to-point networks transmit to a particular device. So this has an example. So what is the example of a point-to-point network? Say mobile communication. Whereas what is the example of a broadcast network? It is television. So in a television network, the television channel transmits to all TVs without discrimination. Whereas in a point-to-point network, your mobile does not transmit to all mobiles in a network, right? It only transmits to whichever mobile you want to communicate to. Okay. The structural diagram of a fiber optic cable is not necessary for you. So this is not necessary. Not necessary. IEEE standards description is also not necessary. Okay, now we come to the layered architecture of OSI model. This is very important. So OSI model has 7 layers, and what we use presently is mostly still TCP/IP layer. So OSI was suggested as an improvement to TCP/IP, but because the top layers, the application presentation and session layer, they have never been properly implemented separately. So OSI model has not been implemented properly. Mostly what we see even today is TCP/IP model, which has 5 layers. So the bottom four layers, transport, network, data link, and physical. The bottom 4 layers, these 4 layers are same for both TCP/IP and OSI, whereas for the top 3 layers are distinguished in OSI, whereas they are same in TCP/IP. They are the application layer. No distinction is being made in TCP/IP. So OSI model, the layer 1 is the physical layer. So physical layer just is the actual connection that you can see. Others are all at the abstraction level. So physical layer actually transmits the electrical signal that contains the bits which contain the information. So physical layer is all you need at the real level. All layers above physical layer are at the abstraction. So next is data link layer. In data link layer, the data packets are being made. So the message is converted into data packets, and then these data packets are transmitted. Next is data link layer. So after that there is the network. So data link layer does error control, frame synchronization, and flow control. These are the main tasks of data link layer. Next is network layer. Network layer provides the switching and routing and creating virtual circuits. So it creates the logical path. So it creates the addresses, as I have said previously, it creates the addresses. So network layer creates the addresses and it switches and routes the data. So it switches and routes the data. Whereas transport layer is responsible for end-to-end delivery. Whereas network layer does point-to-point delivery. So like if there is like one router end device here which goes through one router, and then it goes through another router, and it goes like this. Then say this is H1, host 1, and this is R1, this is R2, and this is H2. Then R1 is, so basically this H1 to R1 or this R1 to R2, these transfers are responsibility of network layer. So these are the network layer responsibilities. Network layer. Then this transport layer is more responsible for end-to-end delivery. Transport layer. Now transport layer does not concern itself with individual routes, but with the end-to-end delivery of the data. layer is responsible for A2. So it does end-to-end delivery of packets. Now, session, presentation, and application are not distinguished in TCP/IP. In TCP/IP, it is shown as application layer. Application layer is the layer that you see at your end. So, if you send an email, the email needs to be next is session, presentation, and application. So, as I said, TCP/IP does not distinguish between these three. An application layer is the application specific end user end application specific user end this font application specific user end specific end user interface. So it is the application specific end user interface. So it is what you see as an end user. So if you send an email, the Gmail inbox and the Gmail app, that is at the application layer. So at the mail delivery protocol, that is at the application layer. So session layer connects two applications. So session layer manages and terminates connections between two applications. So my Gmail to your Gmail, that connection is made using session layer. Presentation layer does encryption, and presentation layer does data formatting. So basically, the data that is in raw packet forms, presentation layer transforms it to a data form that is presentable at the application layer. And application layer is the ultimate user interface which you see as an end user. Now, what advantage does TTM have over FTM in a circuit switch network? So, for a circuit switched network, in TTM, each signal uses all the bandwidth, some of it, while FTM, each signal uses a small portion of the bandwidth, all of it. So, in TTM, you divide in time, so all signals get the entire bandwidth, and thus the main advantage of TTM is that you have high data rate because you get the entire bandwidth to yourself. Whereas in FDM, you only get a small portion of the bandwidth for yourself. Thus, you have a higher data rate. But what is the disadvantage? The disadvantage is low latency. So, UTM gives high data rate but low latency. High data rate but very low latency. Now, comparing analog signal and digital signal. An analog signal is a continuous wave Whereas a digital signal is a discrete wave that so continuous wave means it can take on any possible wave. So an analog signal can take on any possible wave. So an analog signal is a continuous wave that changes over time, period of time. So it can take any, it is a continuous function which can take any possible wave. Whereas digital signal is a discrete wave that carries information in binary form. Next, an analog signal is represented by a sine wave, while a digital signal is represented by a square wave. So analog signal is mostly in communication used like this, whereas digital signal is like this. 0 1 0 1 like this, two states. Okay, and analog signal has no real fixed range. So in practice analog signal has a fixed range, so it is not correct to say analog signal does not have a fixed range, but the fixed range can be anything. So the thing is, the signal can vary from 1 to minus 1, plus 1 to minus 1, or plus 10 to minus 10. Whereas there is a restriction that a digital signal it only take 2 or 3 or 4 values. So the number of values that it can take is limited for digital signal. And also, analog signal is described by the amplitude, period, or frequency and phase. So the three parts of analog signal is amplitude, frequency, and phase, whereas the digital signal is described by bitrate and bit intervals. Okay, next is analog signal is described by amplitude period, and digital signal is described by the bit rate and bit interval. So the two things that describe a digital signal is the bit rate and bit interval. An analog signal is more prone to distortion, whereas a digital signal is less prone to distortion. Why? Because an analog signal has continuous values. So if there is some distortion, some part of the values will get corrupted. So 1.3, you are sending 1.3, so there is a noise of zero point 0.1 that is getting added. Okay, so you have sent 1.3, there is a noise of 0.1 that is getting added, and it becomes 1.4, so there is a distortion. But in digital signal 1, if you say state 1 is all positive numbers are state 1, all negative numbers are state 0. So if you go from 1.3 to 1.4, a distortion of 0.1, you are still in state 1, because all positive numbers are state 1 and all negative numbers are state 0. So if you are in 1.3, you are at state 1. Say you get a corruption of 0.1, a noise of 0.1, and you become 1.4, then also you are at state 1. So your effective state does not change with noise. Thus, digital signal is less prone to distortion. And an analog signal transmits data in the form of wave, while a digital signal carries data in binary form. This is self-explanatory. Now, star topology and ring topology. So, a star topology is a network topology where each individual piece of network is attached to a central node called hub or switch. Star topology is a network topology where each individual piece of network is attached to a central node. The attachment of these network pieces to the central component is so star in star topology there is a central hub and all the devices are connected to that hub. Okay, whereas in a ring topology all the devices are connected in a circular fashion. So each device is connected to two of its neighboring device who are in turn connected to two of their neighboring devices. So like that it forms a circular pattern. So in the ring topology the data travels from node to node, whereas in star topology there are so star topology has an advantage that requires least number of connections. So connections, which is connections, and how many is it? N for n devices. So if you have n devices, the number of connections you need is n, but is highly dependent on bus, on hubnet. And also another point is that is robust to failure of other devices. So it is robust to the failure of other devices. Even if other devices fail, as long as other client devices, not hub, as long as other client devices are failing and not hub, the network will be up and running for the last device also. But if the hub fails, all the network goes down. Whereas the ring network, if one device fails, all devices will fail. If one device fails, all the devices. Okay. Now, so this handles heavier loads. Okay. Now describe the four major functions of TCP/IP. So TCP/IP does internetworking, that is connection of devices. It creates the addresses with which we can. So TCP/IP is protocol is necessary for, like, we need a universal protocol to transmit data so that all devices follow the same protocol and there is no conflict of interest or conflict of the transmission. So to get flow control, error control and everything, we have to have a universally followed protocol. Universally followed and universally agreed upon protocol makes sure that all devices are sent in a similar. All devices send and receive data in a similar way. Okay, now here there is an interesting question. So draw and describe architecture for network using tree topology for an office in 3 stories building. So a tree topology is a special type of structure in which many connected elements are arranged like a branch of tree. Okay, here they have asked to design a tree topology for an office with 3 stories of building. So 3 stories of building means there are floors, multiple floors, and we assume each floor needs multiple computers, so they need to be connected. Now, multiple if we have 3 floors, then we will need a local switch at each floor. So the devices that are present in a particular floor will connect to a local hub in that floor, and the 3 hubs will connect to the main switch of the building. So there is a first floor hub, there is a third floor hub, second floor hub, and they connect to a main switch. Or what can happen is that there is a first floor hub. So this one has all the floors placed equally. So हेलो हाँ 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 कहाँ एग्जिट जाएगा अच्छा ठीक मेरे को मैं एक्चुअली 10 मिनट और लगेगा मेरे को वो NPTEL के एक्स्ट्रा क्लास लगेगा 10 मिनट लगेगा उसके बाद और 10 मिनट 5-10 मिनट लगेगा ठीक है या हाँ कर सकते हो या थोड़ा देर बाद कर सकते हो हाँ ठीक So this is the hierarchical model where all devices are all devices are in a floor are connected. All devices in a floor are connected to the switch at the hub, to the switch of to the local switch of the floor, to the local switch of the floor. Now these local switches are connected to a main switch. Now here this is an alternative arrangement. Here the main switch itself is a local switch of one floor. So instead of creating a separate main switch, one of the switches is working as a main switch. So the other two, say at the second floor, there is a main switch. So that all the devices are on the second floor are connected directly to the main switch, whereas all the devices in the first and third floor, all devices in other floors are connected via their local switches to the device. Now, uh, physical layer is the actual carrier of information between computers. So, what is the physical and data link layer? So, we have described the functions of physical and data link layer, and then FDM and TDM is again discussed. So, FDM divides the bandwidth, whereas TDM divides into time slots. And IP address classes you don't need. IP address classes you don't. And now there another design problem. So here they are asking for a suitable network layout for an organization with 5 departments. So there is an organization for 5 departments. So you have department 1, department 2, department 3, department 4, department 5. So here the explanation is that all departments have local switches that are connected to a main switch. I have local switches which connect to the devices in that load. These local switches are connected to a main switch which connects to the internet. So this main switch ultimately connects all the devices to the internet. But since this is an organization, so usually it does not connect directly to the internet like that. There is a firewall which protects the organization from hacking or other security threats via a organizational firewall. So this is something that all organizations usually maintain to protect their devices from security attacks. So with this we will come to the conclusion of our lecture today, and I hope everyone benefits from it. In the next week, that is upcoming Tuesday at from 6 to 8, we will again have problem solving session. This time we will be solving problems based on the lectures of week 11. Till then, thank you and goodbye.